Last lecture, I had just started with the definition of thermodynamics. I told you that it is the quantitative relationship between heat and other forms of energy. Is this clear? And I also told you that it involves study of heat change during physical and chemical change. So these are two aspects which we talked about. Okay, then we looked at what I would say the drawbacks of thermodynamics. So now that we have decided to study thermodynamics, let us talk about some of the terms involved, because throughout this chapter we are going to hear these terms again and again. So what are the terms involved? So when I am talking about terms involved, first and foremost we have system. So what is a system? That part of the universe. So the definition is, it is that part of the universe. It is that part of universe. It is that part of universe which is under thermodynamic consideration. So what do you mean by thermodynamic consideration? Thermodynamic consideration. So it's that part of the universe where there is an exchange of energy. Exchange of energy is what? Flow of energy is heat. It is clear where there is heat involved. Okay. Then the second one we have is surrounding. So when you are talking about surrounding, what is surrounding? The remaining part of the universe. The remaining part of universe. The remaining part of the universe except system remaining part of the universe except system is called as surrounding. Is called as surrounding. Okay. Now what happens is, so there is exchange of energy between a system and a surrounding and system, vice versa. But there is no exchange of energy from one universe to another. So everything happens within that universe. Is this point clear? So now surroundings are of two types. So when you talk of surroundings are of two types. One is a diathermic and the other is isothermal. So what happens in a diathermic surrounding? In a diathermic surrounding, the surrounding is what you call a insulator. When it's an insulator, it does not allow the exchange of energy from system to surrounding. When is a surrounding isothermal? When it allows the free exchange of what you call energy from system to surrounding. Is this clear? So then after surrounding, so no, surrounding, there will be what you call, boundary. This is not surrounding, this is boundary. See, what happens is, you have a system and a surrounding. Something has to contain the system. Now suppose if I have water, I have to have a glass, kettle, flask, something to hold the water. It is clear. So that part of the surrounding which holds the system is called as boundary. And boundary is of two, that's why I was thinking, I was confused now. Boundary is of two types. One is diathermic and the other is isothermal. So in a boundary which is diathermic, it's basically an insulated material or insulation material, not insulated, it's an insulation material which will not allow the exchange of energy from system to surrounding. Is this clear? Whereas isothermal boundary would be something which will freely allow the exchange of energy from system to surrounding. Is this clear? Now, with this, what happens is, we come to the next point, that is classification of system. Classification, oh my god, so horrible. So we have classification of system. I need not put a. So when you're talking of classification of system, so what kind of an entrance exam question can be asked on this? The first type of classification of system is based on the boundary. Is based on boundary. Is this clear? So what is the type of systems we have? First is open system. Then we have a closed system. And then we have an isolated system. So in an open and closed system, the boundary is isothermal. Whereas in an isolated system, the boundary is diathermic. The boundary is diathermic. So what happens in an open system? In an open system, there is an exchange of both. In an open system, there is exchange of both energy and matter. Both energy and matter between system and surrounding. Between system and surrounding. An example of this open system will be, suppose if you take a tea in a teacup, the escaping steam is exchange of matter and there will be exchange of energy. So ultimately your tea will become cold. Why does the tea become cold? Because the exchange of energy is there from system to surrounding. And also you can see steam coming out, water vapor coming out. That is exchange of matter. So that will be an example of open system. What would be an example of a closed system? There is exchange of only energy. There is exchange of only energy and not matter. And not matter. So only exchange of energy and not matter. So what happens in this case? The same hot tea in a teacup, simply put a saucer on that. When you put a saucer, is this clear? What happens? The saucer helps in condensing the steam back into the tea. So your mass will not become less. Matter is conserved. That matter is, the steam is conserved again back into the tea. But eventually the tea will become cold. Why? Because in this case, matter may not be exchanged, but it is going to exchange energy. It is going to exchange energy. What is an isolated system? Isolated system, it has got a diathermic boundary insulator. So when you have, suppose this teacup, you surround all sides with what you call some thermocol or something like that. What will happen? You will have a, what you call, isolated system. We use this in cooking, I'll tell you. We have these chickpeas, which people in Hindi call as chole. It's a little difficult to cook. See how our ancestors had, what you call, our ancestors nowadays, these people have made a nice this thing. We saw in the YouTube. What they do is, and this another one is that what we call as chana. It's very difficult, to cook. In Punjab and all, they cook this chana overnight, overnight, who will stay awake? See, there's a shortcut to this. What you do is, you have a flask, okay? You put chana and put hot water in the flask and close it. The water is hot for 6 hours. and then if next day you put in the cooker, you will find the chana cooks very well. So this is what they are using. They are conserving the heat. They are giving, instead of boiling it for 6 hours, they are keeping that hot water for that much temperature. Slight temperature difference will be there, but this is an idea, you know. So when you make chole or chana masala, when you try to do it at home, half the time you will find that the chana has not cooked properly. The reason is because it really requires a lot of cooking, and it requires say 5 hours of cooking. Where can you cook 5 hours? Idea. Diathermic boundary. Put it in a flask. There is no exchange of energy and matter. So if there is no exchange of energy or matter for a long time, what is going to happen? The temperature is going to remain 100 degrees. So if it is 4 hours, instead of putting in ordinary water, if you put in 4 hours in hot water, when you remove the next day and just put it in cooker for in 2 whistles, you will get it cooked. Trick. Okay, cooking trip. Chemistry in cooking. Okay, so it's not my idea, I'm telling you. We saw some, some lady was showing this trick. So I was telling my wife that this is thermodynamics basically. Isolated system. It is clear. What is isolated system? There is no exchange of energy or matter. There is no exchange of energy or matter. That means the same tea you put in a flask. It's not a perfect insulator. I mean, after 8-10 hours, maybe the temperature will come down. But that instance, for some time, there is going to be no exchange of energy or matter. It will act as a isolated system. This is clear. So this was based on boundary. So we have, next is classification of system. Classification of system on the basis of phase. Classification of system on the basis of phase. Phase is what? Solid, liquid, gas. So based on this, there are 2 types of system. So remember, classification on the basis of boundary, open, closed, isolated. And classification on the basis of phase is homogeneous and heterogeneous. So the first one is homogeneous system. Homogeneous system. So what do you mean by homogeneous system? When the components of the system are completely miscible. See, when a liquid and a liquid is there, we don't say it dissolves. We use the word miscible. Okay. So when the components of the system of the system, okay, are completely miscible, or in one single phase, then we call it as homogeneous system. The other logic is what? Heterogeneous system. So what happens in a heterogeneous system is exact opposite statement. When the components of the system are immiscible or in 2 distinct phases, this is clear, then they are called as heterogeneous system. So when the components of a system are immiscible, or in two distinct phases, or in two distinct phases, then we say it is a heterogeneous system. Then we say it's a heterogeneous system. Okay. Now what happens is, listen carefully. Okay. Now, when we know the system is there, there is going to be exchange of energy. What is going to happen to the system? What is going to happen to the system? There is going to be a change in the property of the system. It is clear. I will just give a simple example. Suppose if we just take, what you call a kettle and put it in the gas stove. You have exchanged energy. What is going to happen to the system? There is going to be a change of phase. There is going to be vapor getting formed, melting, whatever, something is going to happen. So some property is changing. Now, it's not going to remain the same. It is not going to remain the same. So that is why, since exchange of energy is causing the change in property, we have to understand what are the different kinds of properties of system. So therefore, the next topic that we are talking about is properties of system. So when you are talking of properties of system, what do we have? Property of system is, there are basically two types. Intensive property and we have extensive property. I am leaving space because I have to define, give examples. We will write over here. We have space. Extensive property. So what is intensive property? Intensive property, so from the entrance exam point of view, remember, intensive is non-additive property and extensive is additive property. So intensive property is also called as a non-additive property. It's also called as a non-additive property. What do you mean by non-additive property? Non-additive property means that if you double or if you half the amount, the value does not change. Is this clear? So, if any property which is independent of amount or mass of substance, amount or mass of substance is called as intensive property. So what is extensive property? It's an additive property. It is an additive property. So what is an additive property? Any property of a system, which is dependent on amount or mass of substance will be a extensive property. Now what is the example of an extensive property? Volume. Mass itself is one example. No? So example, because this is an entrance exam question. Identify intensive property, identify extensive property, identify additive property. So that's why I'm giving both the explanation. So example is, because from here I want to come here, huh? I can show you how an extensive property becomes an intensive property. That's very important. Because in thermodynamics, we would like to deal as far as possible with what do you call intensive property, characteristic of a substance. Na? So example, mass itself is an extensive property. Suppose if I have a piece of sodium, I cut it into half and now I weigh it, the value will become half. As simple as that. The value of that property changed. Na? So here your system was sodium metal. Why I took sodium? Because cut with knife, easily. And when you cut it with knife, you made it into half. The value of the property also, what do you call, halved. It became half. So 100 grams became 50 grams. Extensive property, depending on amount or mass. Then we have volume. Suppose I have in this bottle 1 liter of water. Okay. So your flask is the boundary. It is isothermal boundary, because if I keep it in a, the water is becoming cold. It's isothermal boundary. It's a part of the surrounding. Water 1 liter is there. The water is the system. Okay. Now if I just pour out some water or drink some water, which property are we talking about of the system? We are talking about volume. Some property of the same system may be extensive, some may be intensive. I have to tell you that. Because what people generally think while learning thermodynamics is, moment I say water and I say, okay, volume is extensive property, they think all properties are extensive. No. You have a system. Some properties of the system are intensive and some are extensive. Remember that. So for a given system, some properties are extensive and some properties are intensive. So we are at the moment tackling what? For the system water, we are tackling what? We are tackling volume. So volume, if you half it, if this much water I doubled it, it became 1 liter from half a liter. So the value changed. The value changed. So volume is a extensive property. Now come over here to intensive property. Look at density. So what is density? Density is nothing but mass by volume. Density is nothing but mass upon volume. Mass is extensive, volume is extensive, but its ratio will be what? An intensive property. So even if I half the water, from 1 liter I make it half a liter, the density will not change. What else will not change? What other properties will not change? That's why I told you, some properties of the system are extensive, some are intensive. So density will not change, viscosity will not change, okay, refractive index. Refractive index will not change. Its specific heat will not change. But if specific heat does not change, heat capacity will change. Remember that. Because what is heat capacity? Heat capacity is given by the formula mc theta. So the formula itself you have. So the heat capacity of 1 liter water will be very different from heat capacity of half a liter of water. So this has been asked in the entrance exam. So that's why I'm seriously discussing. So heat capacity will be what? Will be an extensive property. Mean molar heat capacity. So when it comes to 1 mole, mean molar heat capacity at constant pressure and constant value, Cp. So Cp and Cv, they are going to be intensive property, because you already defined this much is for 6.022 into 10 raised to 23 particles. You say, let us half it, then it is not mean molar heat capacity, no? It is clear. So specific heat, mean molar heat capacity at constant pressure, mean molar heat capacity at constant volume, these are intensive properties, whereas heat capacity, which is mc theta, mass into specific heat into temperature change, that will be what? That will be a, now one more example I'll give you. See, atmospheric pressure So atmospheric pressure will be intensive, but pressure will be extensive. I remember that. Why is pressure extensive? Pressure is extensive because what is pressure of a gas? 11th, states of matter. What is pressure of a gas? It is the number of molecules of gas particles hitting against the surface of the container. Number of gas molecules. So if you double the number, the pressure will change. If you halve the number hitting against the surface of container, the pressure will change. Is this point clear? So while atmospheric pressure is an intensive property, pressure per se is this has been asked. So people teach pressure is intensive. At that point of time they are meaning atmospheric pressure. But in the entrance exam they are very clear. Atmospheric pressure is different from pressure of a gas, pressure of an enclosed gas. So this is pressure of an enclosed gas, this is atmospheric pressure. Is this point clear? So this is about intensive and extensive properties. As state of system. So when you talk of state of system, what happens is, listen carefully. We say a system is either in a definite state a system is either in a definite state or it is undergoing a change of state, or it is undergoing a change of state. It's undergoing a change of state. There are two possibilities. When do you say that a system is in a definite state? A system is said to be in a definite state when none of its property, when not anyone, none of the properties of the system, is undergoing change. So at this moment, suppose if I am the system, can I say I am in a definite state? Nothing has changed? No, I cannot say, because why? While I am talking to you, my age has increased by 1 second, 1 hour. No? By the end of the lecture, my age has increased by, my blood pressure has remained the same, my body weight remained the same, my body volume remained the same, everything remained the same. But one factor changed, no. My age has increased by 1 hour. So I am not in a state. I am not in a definite state. Is this point clear? So what is it that we have? So what am I in? I am undergoing a change of state. So what do you mean by change of state? Change of state means when any one of the property of the system, when more than one can be there, but at least one, when any one of the property of system is undergoing a change, then what happens? It's undergoing a change of state. It is undergoing a change of state. Okay. Now the next one is what do we have? Now, when the system is undergoing a change of state, the system could be a state function or it could be a state variable. So now let me first explain what is a state function. First of all, state function is applicable for which kind of property? Intensive or extensive, that we have to decide. So this idea of state function is applicable only for extensive property. You will ask me, sir, why it is not applicable for intensive property? Intensive property is a characteristic value, specificity is characteristic value, basically density is characteristic value. What can you change in that? It is not changing. That's why we are saying it is intensive. Na? Extensive property changes, its value changes with change in amount of the substance. Na? Value changes. So state function is a concept applicable only for what? Only for extensive property. So consider an extensive property. Consider an extensive property. So that is the first thing. This is the question they ask, na? Where they catch us in very, very mild things, you know. What is the point over here? That consider an extensive property, okay, which is undergoing a change of state, which is not in a definite state, which is undergoing a change of state. That means some property is changing, which is undergoing a change of state, which is undergoing a change of state. Okay. So it is undergoing a change of state. Clear? This change of state, is independent of number of steps involved. It's independent of number of steps involved. Is this clear? Let's take an example. Suppose we have a system. We are mapping two properties of that, pressure and volume. Okay. So suppose the system is a tire tube. Na? You are putting air into that. So two things are happening. The pressure is increasing and the volume is also changing. So you are changing the pressure. So you can change the pressure in 100 steps. Suppose your tire was flat, the tire tube was flat, there was no air. So you just do one thing, from 0, let's say this is 0. So what happens, from 0 pounds per square inch, you bring it to 30 pounds per square inch. So 0 psi to 30 psi. You did in one step. You just put the nozzle and just waited. 30 ho gaya, I am happy. But then what is the other way? Actually, how do they do? How do the people in the petrol pump do it? They achieve this. First they will put little. They will check 5 psi. Then they will put one more. Then they will say it's 10 psi. And then they will come to this. So here what happens is, pressure, which is an extensive property, pressure of enclosed gas is an extensive property, but it is a state function. It is independent of the number of steps. So it's not dependent that how many steps you took to cause the change of state or change of that property of the gas. Is this clear? Volume, pressure. What is important for us is the initial pressure was 0 pounds per square inch. Now it is 30 pounds per square inch. In the same way, the volume might be about 30 liters, suppose 30 liters of air. I am just taking a guess, it is not the actual value. So what happens is, you just put the air into it, at one stroke it became 30 liters, or you could have added 5 in 6 installments. So what are you going to be bothered about? That you are only going to be bothered about the initial change and the final change. So in a state function, okay, you only think of what it is independent of the number of steps, independent of number of steps involved, and we are concerned with only the initial step and final step. So state functions are those properties of those extensive properties. I am going behind from the backward. State functions are those extensive property of a system whose change is independent of number of steps. It is only dependent on the initial and final step. It is only dependent on initial and final step. Let us take volume. See, the water bottle is the boundary, correct? Isothermal boundary. Water gets hot, cold when you keep it, okay? Water is the system. What is a property we are talking? Volume. Is volume an extensive property? Yes. Now I have to pour this water out, cause a change of state. I can do it in small installments, 10 ml at a time, or I can just pour it in one step. Does it affect the value? No. You had 1 liter, it became, what was the initial? You had 1 liter in this bottle, it became 0 ml at the end. So we are only concerned with the values of initial and final steps and not the in between steps. Is this clear? Then you will ask me, sir, what is the opposite of this? That means, is there some extensive property which is dependent on the number of steps? Yes. And such properties are called state variable. It's a state variable, or it is called as path variable. So what is a state variable or a path variable? Extensive property undergoing change of state is dependent on the path. That's an entrance exam question. Example is an entrance exam question. Let's see, we'll discuss in detail. So what is a state variable or path variable? An extensive property of a system. So everything is about extensive property, not intensive. Intensive are characteristic values. Density, viscosity, refractive index, all these are characteristic values. They cannot undergo change of state. Unless you do something, change the system itself, then the refractive index will change. Suppose you have water, refractive index 1, you put sugar in that, then the refractive index change. If you keep the system the same, the value remains the same. So an extensive property of a system, extensive property of a system, extensive property of a system undergoing a change of state, and it is dependent on the number of steps, on the path followed. What is an example of a path variable or a state variable or a path function? Example, there are only two examples. Work. Example is work and energy. Work and heat, sorry, not energy. Work and heat. So you see work, na? Let's take a physics example. Suppose you throw a stone down, the direction of displacement and the direction of force is the same, positive work. You throw a stone up, what happens? Direction of displacement is opposite to the force of attraction, it's negative work. So in thermodynamics, that's why I taught you on that day, expansion and compression. So in compression, what happens? The direction of displacement and the direction of force, the atmospheric pressure, which is the same. So work of compression is positive, work of expansion is negative. So if I just say there is a cylinder and there is a piston and there is a gas inside and work is being done, that statement is not sufficient for that extensive property work. I have to tell you the path. Is it a work of expansion or is it a work of compression? Because positive work is not the same as negative work. Similarly, heat. If I just say heat, what is heat? Heat is flow of energy. But saying just that is not enough, because you will ask me, sir, is this flow of energy happening at constant pressure or at constant volume? The values are different. So I immediately have to specify the path. I have to say this is heat or flow of energy at constant pressure or at constant volume. By saying that constant pressure and constant volume, I am describing the path followed, because the value is not the same. Value is not the same. So work and heat are examples of path function or a path variable. Okay. So equilibrium. So what is the definition of thermodynamics? I told you, definition, we stick to the textbooks as far as possible. It states that the system is in thermodynamic equilibrium when the state function of the system do not change with time. So a system is said to be in thermodynamic equilibrium when the state function of the system, state function means the extensive property of the system, whose change is independent of the path, correct, is independent of time. So when the state function of the system, is independent of time. To explain this, what we will do is, I will consider simply a gas enclosed in a vessel. Okay. Some gas. Okay. Now this gas has properties. What are the gas properties we have? Pressure, volume, temperature, number of moles. It is clear. It has also a chemical composition and all that. Okay. So based on these state functions, what happens? N is extensive because N is dependent on the N itself is mass upon molar mass. No? There are three types of equilibrium. One is called as chemical equilibrium. So when do you say a system is in chemical equilibrium? A system is in chemical equilibrium when the chemical composition does not change, does not undergo change. I'll give you an example. See, suppose if you have sulfur, you have rhombic sulfur and monoclinic sulfur. Okay. Now what happens is, if you keep it with time, okay, slowly the monoclinic will become rhombic. That's the more stable form. So here it is not in chemical equilibrium, because there is a change. There is a slow change in the property, because monoclinic will not have the same property as rhombic, maybe physical property, but then I am trying to give an example very close to what I am trying to explain. So you have chemical equilibrium. Then the second is, we have a thermal equilibrium. So when do you say a system is in thermal equilibrium? When the temperature of the gas remains constant. You are doing so many other changes. There is a change of state, but temperature is not changing. Temperature is not changing. So thermal is when the temperature of the system does not change with time. Does not change with time, then we say it is thermal equilibrium. The next is mechanical equilibrium. What is mechanical equilibrium? When the pressure of the system remains constant. So we say it is in mechanical when the pressure of the system, does not change throughout. Then we say the system is in what do you call mechanical equilibrium. I'll stop here today because I'm a little too tired today. Okay, and I have to start a new topic called as process.